Now that we have looked at various distributions on the continuous front, it's better that we take up one example across all distributions. What kind of questions can typically crop up, and if we can solve this question, it would be much easier. Now, he is talking about, okay, x is following a uniform distribution. Assume that x is following a uniform distribution between 3 and 8. Tell me the probability of p less than x value less than 6. Or assuming that x is following a normal distribution with mean of 8 and variance of 3. Because in normal distribution, the two items which we would be writing are mean and variance. So assume that the normal distribution is following a mean of 8 and variance of 3. Find the probability of x less than 6. Assume that the distribution is exponential with lambda of 0.5. Find p of x less than 6. Assume that it is following chi-square with 6 degrees of freedom. Find the probability that it is less than 6. Assume that it is following a gamma distribution with alpha equal to 6 and lambda equal to 2. Find the probability distribution for x less than 6. Assume that it is following a log normal distribution with mu equal to 2 and variance equal to 4. Find the probability that it is less than 6. Now, how do I do it with respect to uniform? Uniform is a straightforward. We want x less than 6. We know that the whole area is between 3 and 8. So, between 3 and 8 means the range is 5. The interval space is 5. Whereas what we want is less than 6. Which means between 3 to 6. Which is having an interval of 3. So in uniform distribution, because everything is having a uniform possibility of occurrence, the probability of p of x less than 6 is directly 0.6. So there is nothing much with respect to uniform distribution that can be looked at. It's a straightforward computation, any uniform distribution given for us. Now, assume that the next distribution, which is a normal distribution. Mean is 8 and variance is 3. So what is the way we are solving? I need p of x less than 6. What is the way I will handle in the normal distribution? In the normal distribution, it's always through tables. Any probability finding out in a normal distribution is always through tables. And that tables approach is applicable only for a standard normal distribution. So any distribution, I have to convert it into a standard normal distribution by subtracting the mean and dividing by the standard deviation. So it's as good as saying p of x 8 divided by square root 3 less than 6 minus 8 divided by square root 3. I am doing this minus 8 and divide by square root 3 on both sides. So this is a standard normal distribution now. The left hand side is a standard normal distribution with mean 0, variance 1, which can be referred to in the tables. So what is the value I have to refer to in the tables? 6 minus 0.8 by square root 3. Right? So what is that value like? Equal to 6 minus 8, 6 minus 8 divided by square root 3, which is coming out to minus 1.15. Now I won't have minus 1, so I need z less than minus 1.15, which means the left portion is what I require. But the values will not be there for minus 1.45 in the tables. So I will take 1.45, right? Because symmetry is there. I will take 1.45 above. the left hand side from minus 1.45 will be same as right hand side from 1.45. But the tables will give me the left side of 1.45. So 1 minus whatever I get, I can take it. So 1.154 I can look out for in the normal distribution tables. Whatever is the area corresponding to 1.154. Right? So probably you should be getting a value 0.124. You have that value 0.124, 1.154. So in your table you can check out for 1.15. So this is the value that is coming out 0.8749. So you do a 1 minus 0.8749, whatever is the probability you will get. That because we require greater than 1.15, because less than minus 1.15 is same as greater than 1.15. So but the table gives me less than 1.15. So I take that less than 1.15 and take the 1 minus of that. So if at all something is being given that it is a normal distribution and he is asking us to find out the probability of something occurring, we will do this kind of a process. Now the next thing goes with exponential distribution. Next thing goes with an exponential. Now if you assume that x is an exponential distribution with lambda equal to 0.5, he is asking you to find out the probability that x is less than 6, which you can do the integration 0 to 6 lambda e power minus lambda x. This is what is your integration part. So what you are typically doing, my 0.5 divided by minus 0.5 into e power minus 0.5 x. This is integrated between 6 and 0. So which is typically going as minus of e power minus 3 minus 1. So which comes out to 1 minus e power minus 3. That is the probability. So which works out to us as 1 minus e power minus 3. So it says 0.95. So there is a 95% chance that x will be less than 6 itself, because lambda is nothing but the mean. Right? Or typically the parameter lambda for an exponential distribution, the mean is 1 by lambda. In our formulas we have seen, for an exponential distribution, the mean is 1 by lambda, which is nothing but 1 by 0.5. So average value is around 2. But he is asking what is the chance that it will be less than 6. So generally the probability will be very, very high, because the average is 2. The chance that it is less than 6, there is a big chance. So that's the reason we got the answer as almost 95%. So probably those kind of quick common sense checkups also can very well be done. Now in case of chi-square, again you look at this chi-square 6 degrees of freedom. For a chi-square distribution, we said the mean is nothing but the degrees of freedom. So the average is also around 6. He is asking me the probability that the value is less than 6. So typically I should expect somewhere in the middle itself the probabilities, because the mean of a chi-square distribution is 6, which is the degrees of freedom itself. But we can check out from your chi-square tables for what particular value for 6 degrees of freedom the chi-square value is less than point, what is that, the chi-square value is less than 6. So I can typically go with around 0.42. 42% chance that my chi-square value, now you can go to your chi-square distribution tables. So he is asking you for what are 6 degrees of freedom. 6 degrees of freedom, and the value is 6.5768. That is this typical, this area is 0.5768. So typically this one is giving the other side of the area. So the correct area is 0.5768. If I do a 1 minus of this, I'm getting 0.5768 itself. So here, because this table is talking about the value lying between 0 and 6. The value lying between 0 and 6 is this much. So you can very well give that this area is 0.5768 directly. Getting less than 6. Getting less than 6 is the value that is being the shaded area here, which is what is coming out as 0.5768. Now, so for chi-square, for normal, your dependency is primarily on the tables itself. Right? For gamma, I'll again come back. But let's look at log normal. Easy to do. If I am saying log normal with 2 and 4. So what is the intention for me? Here, x is actually a log normal distribution. Right? So log x will be a normal distribution. So what I have to do if it is log normal is first do a log x. Probability of log x less than log 6. So what is log 6 here for me? Log 6 is 1.79. So my question is not probability of x less than 6. This is the biggest mistake. Right? I have to make it as probability of log x less than 1.79. Right? So now this I have to convert it into standard normal. So probably it is like probability of log x or log x minus mu, which is 2, by sigma, which is again 2, is less than 1.79 minus 2 divided by 2. This will become my standard normal. So 1.79 minus 2 divided by 2. So which comes that z should be less than minus 0.1. Again, the table does not give you minus 0.1. So I can take z greater than 0.1. Z greater than 0.1, but the table gives z less than 0.1. So do a 1 minus of that and you will get your probability. So for 0.1 you check out. For 0.1, initially itself is there 0.5398. If you are talking of z 0.1, you are getting 0.5398. The first row itself. 0.5318, because your z is 0.1. You will get 0.5318. But you require less than, not the greater, you require greater than 0.1, because we wanted less than minus 0.1. So I will take 1 minus of this and it becomes 1 minus 0.53, which will be somewhere around 0.47%. Even if I use the formula here, I should get the same number, 0.46 or 0.47%. Right? So that's how we convert anything that is given in any kind of a distribution. We'll actually plan out to find out the probabilities. So which means what it is telling me, just by knowing the parameters of that distribution, mean and whatever are the key parameters. So for normal distribution, I need 2, mean and variance. For uniform distribution, I need 2, which are the intervals. For exponential distribution, I just need the lambda. For chi-square distribution, I just need the degrees of freedom. For log normal, I need mu and sigma. For a gamma, I need alpha and lambda. Just by knowing that, I can find out any probabilities. That's the simple thing which we are trying to drive in this example. The others I'll take up in our next session. Right? We'll try to work out on the remaining numericals tomorrow itself.